Good morning, everyone. I'll just do a quick overview of what we're doing today. Most of the time you'll have to kind of work on the homework on your own or with help. I'm here for answering any questions. There were the last two videos, the recordings of the lecture. The audio broke off about partway through, so I did record last night that part that was silent. I re-recorded it. So that would be for today's Wednesday. That was Monday's lecture and Friday's lecture both happened. I'm thinking it was because of my microphones probably lost their charge. So I was charging them up last night and left them at home, but we're using this microphone here for anyone who's not in class. So just a quick overview. We took a look at the random variables, discrete and continuous, on Monday, so that is recorded. It is one homework, about 13, maybe 14 questions, I think, in WebAssign. Friday we'll pick up with the binomial distribution 9.2. We've got 9.3, 9.4, and then we'll have an open day again that following Friday for work in class, get caught up, and then we've got just two more sections after that, probability density 9.5, and then the mean variance, and then we've got a lot of time for review the whole last week. What I want to get you thinking about is to start going through the exam 3 review as you work through things. I think it'll, I'll pull it up here, take a look. Maybe I'll download it too. Sometimes that's faster. Yeah, downloaded pretty quick. So here's 8.5, which we've done, Bayes' theorem, a couple types of questions. Remember, these are created by the course coordinators who also create the exams. So generally they're fairly close to the types of things they're going to be asking. Generally it'll be about 10 questions that are either multiple choice or fill in the blank, and then 3 or 4 show your work type questions. So there's, those questions with the Bayes' theorem, and then with the discrete random variables, which we just did on Monday. Again, maybe work through the homework, but you can also take a look at these to kind of see what the test questions might be looking like, what you really need to know. So there's a couple examples in here to work through, and then we've got Friday stuff. What you'll see, 9.3, 9.4, and then there's some P1, P2. I looked over these, I couldn't find anything. This is really, I think they could take the P1 off, which we kind of incorporated. All that P1 does is give us continuous random variables, so you just have to sort of be able to identify it. But there is a section for the P2 part. There's the normal distribution, and then there's this stuff on P3. So we'll get to those stuff later. There's the answers down here. But kind of as we go through, if you can kind of at least take a look at it, maybe read through the questions. Whether you work on them now or not, that's up to you. Again, as we get closer, we'll have that whole week to also work through them. But I think sometimes if you at least look at them and then you go back to the homework, you see which one of the homework problems are maybe more important for the ones that look more like this. And I think with that in mind, we have a higher probability for being very, very successful on exam 3, because there's not as many days of instruction. There's more time involved to kind of go through and learn it and fit it in with your other classes and the other things you do with your life, which are multitude. So today we've got that breathing space to kind of work through things. Did anyone have any questions in particular that might be good for everyone? Yes.
Can you go over number 14C?
14C, that sounds like the hard one, because they get harder at the end, right? Okay, sure, that would be a good one. Let's go. Incidentally, I don't work through all the homework ones in advance. Something my mentor taught me. I do look over some of them, but I find also if we work them together without me having too much practice beforehand, then you get to see the way to think through them. Let's see. 251. Okay. Courses. And the other thing, the way this is set up, when I pull them up for my view, it always gives me the answer. So at least I know what I'm working towards, but and we'll also look at the way yours may be a little different. This for the 9.1, the recent, okay. So this is discrete or continuous random variables. Oh wait, was it for Bayes' theorem or? This is only showing 6 questions. What's going on here? Oh, there, okay. It's just maybe the view. I thought there was, I have a bigger screen so it shows more along the top. So that's why I was going, wait, where's all the other questions? Here we go. Okay. So again, it does show us all of these, but we'll try to pretend that the answers aren't there. I haven't figured a way to turn those off. It's kind of distracting. But the following table shows the number of males in a country in 2000, broken down by age. Numbers are in millions. So these are millions of people. Oh, I have to turn this thing on. 1, 2, 3. Here we go. Okay, so we've got these numbers here. Construct the associated probability distribution. So what we have to do is we have to get the sum or the total. And then what we will do, the probability is really kind of like a relative frequency. We're getting the percentage of each age group, really, right? So we can do that with, yeah, maybe I'll just, of course, your numbers aren't going to be the same, but so we can focus on the process. The thing is if you make an entry error or something, I could take a look and maybe, because that's what's usually is going to happen here. But we would get the total here, whatever it is, we'll call it T, and then to get 0 to 18, you're going to take, to get this number here, you're going to take 36.6 divided by that total.
Yeah, my question though is how do number C, because not number C, letter C, this is 15.
Uh-huh.
It goes from 0 to 18, so how do we find what 15 is?
Let's see. Okay. Use the distribution to compute the following. 25 to 65. Greater than or equal to 15. Exactly. Use the distribution to compute the following. Round your answers to 4 decimal places. They've got a number. I'm assuming, well, we've got less than 18, so that's, I can see that one. I don't know. The data, there's no way the data breaks down to let us know, right? Because they tell us only 0 to 18. They don't tell us anything about 15. I would say that that question can't be answered. We could estimate, and I guess that's maybe what they're doing. I would maybe take these out, but that's not what they've got, because that's 25%. That would be like 74 point something, right? They've got 78, but I don't see anywhere here where we would know how many there are from 15 to 18. That's what we would need to know. That is really weird. Yeah, it's unless it's a typo and it's supposed to be greater than 75, but it's that the number looks like about greater than 18, and what they've got is somehow they were able to figure out or get that data, but there is no data here that tells us 15 to 18. It's what we would need. I'll have to contact the publishers and see what were they thinking. Anyone else have, you see what that, but that does, if they're gonna ask the question, all we have access is to the data, and if they're gonna want greater than 15, we need to know some more details about this setting. All we know is that between zero birth and 18 years, there's 36.6 million, but we don't know if they're all really younger or older, or we don't know how many are 15 to 18. So it's that question C really, it can't be answered unless they give us something more. And I don't see, yeah, that's a good question. I'm glad you got stumped on it, because I'm stumped. I might go back in with these answers to see what they're doing, but I can already see that they're assuming that there was about 4% that were from 15 to 18, but I don't see any way that they could have, with what they gave us, that could become arrived at. Yeah. Yeah, sometimes in the fine print somewhere they'll tell you something like that, but they don't. X is greater than 15. Wait a minute, what is where X, and it's not very well defined. They don't really tell you what the random variable is, right? They just give you the data. I guess they're assuming, from the way they got it, that I would assume that X, the variable data, is the age, right? So 25 to 65, we could get that because we've got 25 here, we've got 65 here, so we could add these together. That makes sense. Less than 18, well, again, this is a little, even that is ambiguous, because we've got 18 on this side and 18 on that one. So if someone is 18, are they in the lower end or the upper end? It's not clear. It's not clear from what they're saying. Are the 18-year-olds here, or are the 18-year-olds here? Less than or equal to 18. So again, from their answer, I can see they just want this one, but
I tried checking the course book, and they didn't actually have these problems in their homework section.
they didn't.
They didn't.
Okay. I'm not sure what. Yeah. So this is a very poorly asked question. Some of these, let's see if they. Yeah, see, this is P1. I couldn't even find P1 in the book. It's supposed to be an appendix, so I don't know if it came from a previous version. I know some of these are custom-made questions. You'll see Fishman, which is another professor here, who's actually created some of the questions, so those we wouldn't find in the book either. This, because it's coming out of section P1, which I don't know where that is. I looked through the book itself. I can't find them, so you're probably not going to find these type. And so it may be that it was constructed, I don't know. I'll bet you it looks like a textbook question, but maybe from a previous one or something, and it's very poorly mathematically worded, because again, all these overlaps, 25, do they go here or here? That's that could make a big difference. So when you have, and that's why usually when they do bins, they would do something like 18 to 25.5, and then over here would be, so the half of the way. So it's kind of like, oh, the 25-year-olds are here, 26-year-olds are over there. But this way of listing them is not very helpful. Yeah, all of these, they've got these 65-year-olds. Are they this side or are they on the right side? So that's problematic. And then there's no way to answer this. They answered it, but they must have had access to additional data. So we'll throw that one out. The other ones were okay?
Yeah.
Okay, so but they're kind of the same, similar problems to like this one, but at least they're asking for intervals that you have a midpoint, and we're okay with that, I guess. And but we'll thanks for letting me know. I'll watch for that because it's problematic. Yeah. Now everyone, don't spend your time on 14C. It can't be done with the data they gave us. So good. Anything else? Or you want to just keep working? And all right. So I'm here for you. I also got the office hours, so you can stay for 2 hours, get all the work done, or go get some breakfast or whatever you want to do. But just if we keep on track, and then take that time to look at the test review as we go, you'll feel very well prepared for all of this. And then again, we even have that buffer of a whole week before finals week, and then our finals not till Thursday, so there's that whole part of finals week as well. So it's almost 2 weeks. So all right, so we're going to stop the recording here, let you go ahead and do your work, and thank you for that question.